Okay, so in this video we're going to go through the equations of a straight line graph. Now, one thing we need to think about when we're looking at graphs is, what are graphs? Well, to kind of explain to start with, they're not charts. Quite a lot of times you'll see this interchangeably use, these two words, charts and graphs. Here's a graph of, I don't know, annual wages or something like that, or the weather. Or we see here these examples of charts. These are not graphs. They don't typically have any mathematical relationship between them. They just represent data. So how sales figures would be another example of it, or the weather, as I said. But they represent data, but there isn't necessarily any mathematical relationship between that data. The difference is graphs have a mathematical relationship between the variables in them, which in the case we're going to be looking at is going to be the X and Y variable. So if you hear anyone talking about something and say, look at this graph of how many units of this we've sold, they are wrong. This is a graph. So straight line graphs, what we're looking at here, we're not looking at curves. Curves, that'll come later in the subject. It gets a bit more complex. But when we're looking at straight line graphs, they will follow this rule of Y equals mx plus c. Now, don't panic if you think algebra, this is going to be complicated. It's not. So here is a graph. It follows the rule. All straight line graphs follow the rule of y equals mx plus c. So this follows that rule. In this case, we've got m equaling 1 and c equaling 0. So for this, y is equal to x. So every time we go along 1 on the x-axis here, then we go up 1 on the y-axis. So wherever we are on x, so when x is 5, then y will be 5 because y equals x. But if we change this number in front, m, this is our gradient. That's an important thing to remember here. The m, this bit before, let's multiply by x. This is our gradient figure. So if we move this to 2, control, okay. So now y equals 2x. So whenever, if x is 1, then 2 times x is equal to y. So 2 times 1 is 2. If we go along here to 3, well, 3 times x, so sorry, 2 times 3 is 6. So if we go up here, y is 6, which is correct. But what this allows us to do is to calculate way off in the distance, that way or that way, wherever we go. So I know that when x equals 8, well, by this rule, 2 times 8 is 16. And if we followed it up here, then it would be 16. We've not actually got to go up there and do that. We can calculate it. But what about this c figure at the end here, this constant? This constant, as we move it, you see it moves the graph up. Or if we go negative, it moves the graph down. And basically what this figure relates to, let's move to 2, is where it crosses this y-axis line. So before we had it where it was at 0 and it kind of disappeared out the bottom, y equals 2x. Because obviously we won't write plus 0 because there's no point, is there? But if we move it to 2.1, then where it crosses that line is 2.1. If we move it to 5, then it crosses the line here at 5. If we move it to minus 3.7, or well, somewhere we can see, so minus 1.9, there, look, it crosses the y line at 1.9. So this figure here, the m figure, controls the gradient. And this figure c controls where it crosses this y line. Now, what I didn't say before was this alters the gradient to make it steeper. So whenever m gets bigger, then the gradient gets steeper, like the hill gets steeper going up. But when it goes to 1, it becomes equal to x as it goes along. When it becomes 0, then it disappears out altogether, because if m is 0, whatever the value of x is, if you multiply it by 0, it becomes 0. So if we come along here to 4, then 0 times 4 is 0, plus 2.2 is 2.2. So basically, it will be a straight line graph all the way along. It has no gradient. If you were to put a marble on top of here, or a ball, it would stay exactly where it is. Where if you altered the gradient a little bit that way, even a little bit, you put a ball on top of there, it's going to roll down the hill to my left, but probably to your right. If you move it this way, negative, then the gradient goes the other way. So every time you move along here, so you've got, let's move this back to 0 quick. So y equals minus 0.5 times x. So every time we go along, we go to x equals 1. So 1 times minus 0.5 is minus a half, and there we are, minus a half. When we come to 2, 2 times minus a half is minus 1. So when x is 2, y is minus 1. These are the critical bits we need to know about. M represents gradient, how steep the hill is. And positive or negative means whether it's tilting up or whether it's tilting down. And C is the value of where it crosses the y line. If it's negative, it's below the x-axis. If it's positive, it's above. Okay. So let's have a go at some examples of these. I'm going to go through the first bits of each part of the worksheet if I can. Shouldn't take you too long to do. Actually, this worksheet is fairly quick to get through, but actually it will reinforce this because it's an important. Straight line graphs come into loads of different topics to do with engineering. So for electronics and stuff like that, we often use straight line graphs. And in the next video, we're going to look at simultaneous equations, which is where we've got two straight line graphs, and we're looking at where they cross over as being a point of interest. So this worksheet, by the way, is in the link down below. So I'll go through just a couple of these, and you can go through those on your own. Write down the gradient for each of these lines. Well, it's not a trick question. It's as easy as it looks. So here, look, 3. That would represent the gradient because we said m is the bit multiplied by x. So in all of these, it's just the number in front of the x value. The only time that might get a bit complicated is where you've got here minus 4. Remember to include the minus. And here when it's a fraction, but it is the whole fraction, minus 4/5. So what would that look like? Just look at those couple of examples. You don't need to draw this, but just so we can imagine it. 3x plus 1. So going back to our example here, 3x, let's change that to 3, plus 1. There we go. So that's what that graph would look like. And the gradient is 3. Every time we move across 1, the graph goes up 3 points. But it crosses the line here at 1 because that's the value of C. But that question is just asking for the gradient, which is the number in front of each of these. Next, write down where each of these lines crosses the y-axis. So this first one we've got y equals 2x plus 3. Well, we said before that where it crosses the axis, we'll change this to 2. So that's the graph of that formula, which is 2x plus 3. Well, it crosses the line here at 3, look. That's where it crosses the y-intercept line. So it's often referred to as the y-intercept. That's worth noting. So actually where it crosses the line is 3. Crosses it at plus 3. This one crosses at plus 1. Here we've got minus 2 because it's below the line. And so on. I'll let you go through the rest of those. But it is that number that's added to the end that hasn't got an x related to it. So it's not a multiple of x. It's just the number that's tagged on the end. Sometimes it can be at the beginning, but in these cases it won't be. Okay. Write down the equations of the lines below. So a gradient of 3 and an intercept of 6. So just go back to our equation. Remember that this is our gradient And this is our y-intercept. So when we're looking at this here, I'll write A just down here. So you can see it. Has a gradient of 3. We'll gradient's the M figure, and a y-intercept of -6. So it's going to cross the line at -6. And it's as straightforward as that. Sorry, it says +6. Question 4. Does the point 2, 5 lie on the graph y equals 3x plus -1? So remember, with our coordinate system here, if we were to draw this as a graph, better with a ruler, that this crosses at -1 and goes up at something like that, probably a bit steeper than that. So the first number is where it is here, 2, and y is this value here, 5. So does it lie on there? Well, actually we don't know. I've not drawn that scale yet. But what we can do is we can calculate the value of y when x is 2. So we've got this equation that says y equals 3x minus 1. Well, what is the value of y when x is 2? Well, let's put that in. 3 times, and I'll put in brackets 2 because it's a variable, minus 1. Well, 3 times 2 is 6. And 6 minus 1 is 5. So at 2, it is actually on that line because it is 5. So that is true. It is on there. Let's just do a graph to scale to show what we mean there as well. It was 3x minus 1. Now at that point, look, 2, when x is 2, y is 5. So it definitely does go onto it because that's the point there, 2 and 5. So if we substitute the value of x in here to x, we substitute the value 2 into there, then this becomes 5, and that definitely lies on that line. Let's have a go at B to see if that works. I'm going to rub this out. So does the point 4, x equals 4, and y equals 1 lie on the line, same line? Well, this is B. Y equals 3x plus 1. It's a different graph actually, it's plus 1. Does it lie on there? Well, when x is 4, so that's 3 times 4, put it in brackets because it's a variable, plus 1. Well, 3 times 4 is 12, plus 1 equals 13. So that's not on there because when x is 4, it does not lie where y equals 1. Actually, y is 13 at that point. Let's look at the graph. So it was 3x plus 1 this time. 3x plus 1. We're looking for the coordinate point, let's say 4 and 1. Four across and 1 up. So 4 across and 1 up is here, where my cursor is. But actually, that's nowhere near this line. So we can be sure that it never ever appears on that line. So I'll let you have a go at the rest of them. So question 5, work out the equation of each of these lines. This is more straightforward than it seems. We just need to gather some information from it. What we need to do is we need 2 bits. It's going to be in the form of y equals mx plus c. So we need to find m and c to get the equation. Well, C is where it crosses the line. And in this case, of this one here, C equals 4, because it crosses the line at 4. What's the gradient? Well, the gradient is how much it goes up for how much it goes across. So every time this goes across 1 here, so across here, it goes up 1, 2, 3. So M will equal 3. So the equation for this will be y equals 3x plus 4. So we'll go to a couple more. So this next one, we need to find a value of C. C is where it crosses the line here, 5. And then we need to find the gradient. Well, every time it goes across 1, it goes up 1, 2. So M equals 2. So our gradient, y equals 2x plus 5. Fairly straightforward. Just to make, I think the others you could have a go at there, but E, obviously when it starts to go the other way, that gets a bit more challenging. Let's have a look. So we need to find M and C. So C here is going to be equal to 6, because that's where it crosses the line. And every time we go across 1, it goes down 1. So the gradient here will be minus 1. Now we don't normally write, we can write it, doesn't matter. So minus 1x plus c. You'd be okay though writing equals minus x plus c. We don't need to write the 1 in front of it, because when we multiply things, 1 is an identity. It becomes the same number. One more go with a negative. So here we're looking at our value of c is 2. And our value of m is, well, every time we go across 1, we go down 1, 2, 3. So that's a gradient of minus 3. So our equation, y equals our value of m minus 3x plus 2. Slightly more challenging here with question 5. I'll only show maybe 2 of these. So we've got 2 points on the graph, and it's asking us to calculate the equation for these. First off, all of these give points where it actually does cross the y line. So your value of y is always the second in the coordinate system. So here, c will equal 5. M is the gradient, how much it goes. Well, actually, if we look at the gradient, let's calculate gradient. So M is going to be the change in y divided by the change in x. The change in x is going to be, it's going from 11 minus 5, because here our y value is 11, here it's 5. So that's the difference between them. It's going to be 6, but 11 minus 5 divided by the change in x. Well, x goes from 0 to 3. So 3 take 0. And if I put that down here, that's going to be equal to 6 divided by 3, which is a gradient of 2. So our equation for this one is y equals 2x plus 5. A bit more complicated there. Let's have a go at the next one, and then we'll have a go at a negative one as well. So for question B, we're crossing here, y, it crosses the y line here at 3, so C equals 3. The gradient, M, is going to be equal to the change in y. Well, y goes from 3 to 17. So that's 17, take away 3, divided by, and then the change in x. Well, x goes from 0 to 2. That will be 14 divided by 2, which is 7. So that's a gradient 7. So the equation of this line is y equals 7x plus 3. Okay. Negative ones are pretty much the same. You just, well, let's just have one go to a negative one, and you go to the other one. Exactly the same rules, but we just have to be careful with negative numbers. So where it crosses the line is here, where it's 8. So in this case, this one, C equals 8. And the gradient, M, is going to be equal to our change in y. My y is going from 8 to 4. So 4, take away 8. It's going to be a negative number. It's going to generate a negative. And it goes across 8. So 8, take away 0. That will give us minus 4 over 8, which if we cancel that down should give us about minus a half. So that's our gradient. So for this, y will equal minus 0.5 x plus 8. A bit more complicated, always is when it comes to negative numbers. Find the equation of the straight line graph that passes through these 2 points. My advice here would be to plot it. Okay, so if you're doing this, it is worth plotting it. If I can zoom out a bit, we'll have a go. It's a bit more difficult to see, but let's just have a go at this. So we're looking at that passes through 0 and 3 and 4 and 19. So always good skills to be able to draw a graph. This won't look amazing, but it'll be a representation. So let's think about our range here. So these are going to be in 2s. And across here, we're going to use a bit of a different scale across here because we're not going across as far. We're going from 0 here to 4. So 1, 2, 3, 4. Roughly distance apart. So 1, 2, 3, 4. Better off drawing this to scale. Now we say it crosses through these points where x is 0, which is this line here, and y equals 3. We're going to use a different colour. X equals y equals 3. So we're still halfway between there. That one. That's where it crosses the line. That's one of the points here. And the other one is 4 and 19, which is sort of halfway between 18 and 20. So if we go across it, it's somewhere around there. Now if we get a line, you can get a ruler to do this, but basically if you join these up as best you can, about there somewhere. That's what it looks like. They're the 2 points, and we just joined them with a ruler. Now you don't need to do this to calculation, but I think it helps you visualize it. So let's do this calculation. Well, we know that C is going to equal 3 because it crosses there anyway. So C equals 3. That's where it crosses the y-intercept. The gradient. Well, every time it goes across 1, it goes up. Well, we can work out the gradient. Let's do the proper calc. The change in y. So 19 to 3 divided by our change in x, which is from 4 to 0. 19 take away 3 is 16, and 4 take away nothing is 4. 16 divided by 4 is 4. So now we've got our value for m and our value for c. So that gives us y equals 4x plus 3. Bit more complicated, but in the real world, that's probably what you're going to get in engineering. You're going to get a couple of values. You need to work out what the gradient is, work out a formula for this. So an example of what this might be is something like a thermistor, which if you've not come across yet, is a resistor that changes its temperature with temperature. So is a resistor which changes its resistance with temperature. So what you'd want to do is you'd want to find a few points. You want a known temperature, like, I don't know, 0, ice in a glass, and you'd measure the resistance, take a point, and then you'd want another known temperature, like boiling water, put the temperature sensor in, measure the resistance, and then use temperature as your bottom X scale, so 0 to 100, and then resistance at the side, put your 2 points on, draw a line between the two, and now you've got a gradient and an offset. And then you can use this to calibrate your thermometer to be able to calculate other stuff and put it in as a sensor, so that you know that when the resistance is 20 ohms, that it's 40 degrees Celsius. And when it's this temperature, so this temperature, it's this resistance. And you've got a rule for it then. Okay, so more often than not in engineering, when this has some practical use, you will be given just a couple of points and you'll need to calculate the value from it. Okay. Find the equation of the straight line that passes through and has a gradient of 4. So let me just zoom in a bit more. What's it asking for? Find the equation of the straight line. So this is going to be in terms of, we'll go back to a better color. It's going to be equation of a straight line, y equals mx plus c. It's going to be in that form. That has a gradient of 4. In this question, I already know then that m equals 4. And that passes through the point. This gets a bit more tricky. We're looking for c. So it passes through the point 1 and 10. So let me just draw a sketch of what that would look like. Oops. So it's a graph like this, and it's got a draw it as a straight line, well, straight as I can draw. Now, I can move that around all over the place, but what it does tell us in there, that when it passes through this point here where 1, so here's 1 on x, and passes through, I don't know, 10, which we're going to say is up here somewhere. So what we now know is that this graph line here passes through here, where we've got 1 and 10. But where does it cross through here? Because that's our C value, isn't it? Well, we know that for every 1 it goes across, it goes up 4. Therefore, for every time it goes back this way, it goes down 4. So working back, that's going to be 6, isn't it? Because it's going back 1 and therefore down 4. So our equation, so our value for C here is going to be 6. Therefore, our equation for this will be y equals 4x x plus 6. Bit more complicated, got to kind of work backwards, because you won't always be given a value where x equals 0 that nicely fits onto this line. You might have to imply it. Let's do that again, but for the next question. Just one more go at that. Again, straight line graph, so it's going to be y equals mx plus c. So b has a gradient, I'll write b here, so there's a gradient m of 2 and passes through the point -3 and 3. Well, this is a bit more complicated. Let's look at this. So I'm going to go 1, 2, 3. This is -3, -2, -1, 1, 2, 3. And it's saying when x is -3, then y is 1, 2, 3. Is here. And y is 3. So it definitely passes through this point there. And it has a gradient of 2. So let's draw a line with a gradient of 2. So a line with a gradient of 2 is going to be, every time it goes along 1, it goes up 2. So it's going to be like that. Like that. So I think. But we know it crosses through that line there. Now it's going to carry on, and at some point up here, oops, cross over here. Okay. So we know that every time it moves along 1, it goes up 2. So this is 1, and this goes up 2. So when it goes along, so from -3 to -2, we're going from 3 to 5. And then we go along a bit more to -1. We're moving along here 2 now, so we're going to move up here 4. So 6, 7. Way higher. So if we're going to go to 0. So we're going from -3 to 0. So we're going 3 along that way. So we must be going 6 up that way. Well, we already started at 3, so another 6 up. C is going to equal 9. So y equals 2x plus 9. Crosses through there. If you draw this graph out, though, you'll see that it crosses at 9. If you're not sure, make sure you have a go for yourself. So, next point here. Let's go to question 9. We'll go to question 10, because that's all we need to do for what we're doing. So we've got points here of nothing crosses through 0 in this case. We've not got any of those values, so we're going to need to work out everything. First of all, we need to work out gradient. Gradient is m on y equals mx plus c. So our gradient, remember our values of y are here and here. So we're going 8 minus 2. They're both above the line, so they're both positive numbers. But we take them away because it's the difference. And we're going from 3 minus 3. That's where it can get a bit tricky. Double negatives. So what's that? That's going to be 6. Because 8 take away 2 is 6. Divided by 3 take away -3 is going to be 6. Because we're adding double negatives. And that's going to equal 1. We have a gradient of 1. Now, that means for every time we go across 1, we go up 1. Fairly straightforward. So here, if I zoom in, we know here that we're going to go across 3, aren't we? From -3 to 0. 1, 2, all the way to there. And every time we go across 1, we go up 1. So if we're going across 3, then we're also going to go up 3. Well, we started at, this was 2 here, the height, and we're going up 3. So this point here must be 0, 5 as coordinates. So our value for C has got to equal 5. So the equation for this line is going to be y equals 1. We don't write the 1 when we're multiplying it because it's an identity. So it's equal to x plus 5. Bit more challenging there, a lot of work to go in to find that. Although, ironically, in engineering, you'll tend to find it's more common to have it like this. You never get the values you want. First thing, calculate gradient. M equals change in y. Here's our values of y. 19 take away 13 divided by our change in x. And that's going to be 3 take away 1. 19 take away 13 is 6. Divided by 3 take away 1 is 2. Cancel that down. We're left with 3. We have a gradient of 3. Our value for C, well, we're looking at this point here. So this is here. Let's mark it on. 1 and 13. We know for every time it goes, we've got a gradient here, for every time it goes across 1, it goes up 3. Therefore, every time it goes back 1, it goes down 3 points. So this point here, it's got to be 13, take away 3, which equals 10. It crosses the line at 10. So y equals 3x, our gradient figure, plus 10. And finally, question 10. Again, these are just like these. These are supplementary questions, really, because these are just the same as these, but you're not giving them on a graph. You're just giving them as points to plot. Have a go. They're just practice makes perfect, really. Same sort of thing. So question 11 gets a little bit more challenging, but not impossible. So here we've got an equation 2x plus 6. So y equals 2x plus 6. Where does it cross the x-axis? So what this is effectively asking is, we've got this equation. It definitely crosses the line at 6 here. And it's going up at positive gradient. It says, where does it cross the x-axis? Well, it's going to be somewhere back here, isn't it? That's effectively, I'm sorry, I'm in the way there, aren't I? Let me move myself out of the way. So it passes through here, which is 6. But at some point in the past, back here, it passes through the x-axis. But where? Well, let's think about this. Every time we go back this way 1, we go down 2 because of the gradient. So when we go back to -1 here, when we go back to -1 here, we're going to come down by 2. So we go from 6 to 4. When we come along here a bit more, we're going to come down another 2. So when we come down to -2 here, we come to 2 here. And then when we come along here, we cross here at -3. So without drawing it each time, though, how are we going to work that out? Well, actually, what we're looking for in this equation is when y equals 0, because that's when it crosses the x-line, when y is 0 here. Well, what conditions would make y equal to 0 here? You've got to have something multiplied by 2 plus 6 that equals 0. Well, let's make that the case. 0 equals 2x plus 6. Well, let's rearrange it. Let's take 6 from both sides to start with. So minus 6 equals 2x. It's true, we've done the same to both sides. We took 2 from both sides. Sorry, we took 6 from both sides. Now we need to get rid of this 2. So if we divide both sides by 2, we get minus 6 over 2 equals 2x over 2. Well, they cancel out. So we're left with minus 6 divided by 2 is minus 3 equals x. Well, that's the case, isn't it? Back here, when x is minus 3, y is 0. That's where it crosses the line. So what we need to do to make these when they cross the line is set y to 0 and look for the condition where that's possible. So when we type that in, so for example, with this equation here that we just looked at, 2 times minus 3 plus 6. Well, 2 times minus 3 is minus 6 plus 6. Minus 6 plus 6 is 0. So that is the occasion where y is 0. That's when it crosses the line. This actually, the next question, if you're going to go on to this one, is nowhere near as challenging as it looks. It's just worded differently. It is y equals mx plus c, but it's all the wrong way round. So what we need to do is to rearrange this to make y the subject. So if we take x from both sides, I'll draw it down here. So we've got x plus y equals 10. If we take x from both sides, we've got x plus y minus x equals 10 minus x. Well, plus x minus x is 0. So we've got y equals 10 minus x. Now we could leave it like that, but you could do, or you could write it as y equals minus x plus 10. Puts it in the form of y equals x plus c. But that's the equation of that one. Let's have a go at question C then, just to do another one. So C, we've got 2x plus y equals 6. Well, if we add, or let's just take away 2x from both sides. So minus 2x plus 2x plus 6. So took 2x from that side and then take 2x from that side as well. Well, clearly this cancels out on this side, so we're left with y equals 6 minus 2x. Again, we can swap that round if we want to say that y equals minus 2x plus 6. There is a plus in front of that 6 there. We don't write it because it's positive. There's no need to. If there's no negative there, we assume it's positive. But when we put another number in front of it, we need to put the plus back again. So that would be the equation of that line. The others, I'll let you go through. They are more challenging, but if you got to that stage, they are supplementary information to get to that point. Okay. If you've got to this point and you've had to go at all of these, hopefully by this stage you'll understand straight line graphs. The next thing we're going to look at is simultaneous equations. These are where we've got two straight line graphs and they cross at some point, and where they cross is a point of interest, allows us to work things out. So have a go at these first and you'll be all set for simultaneous equations.